calling you back to the Oregon Caves. Okay. So I love the fact that my first question is, have you visited the Oregon Caves? So tell me, how many of you have visited? Great. How many of you stayed in the Chateau?
Great. Hasn't been open to stay.
I know. How many of you took a cave tour? Excellent. All right. Sometimes we don't have so many that do that. Oh, and how many, did any of you work there? Silence. Okay. Yeah, I know. Alan said the lodge is closed. I am so sorry. You don't think I don't want to get it open. Okay. So I'm just going to give you a few minutes about the cave, the chateau, and kind of what's going on up there with the restoration. One of the reasons why I'm here tonight is I saw Daniel at a meeting and I said, you know what's interesting is the Oregon Caves is working in historic preservation, which is both the National Trust and Restore Oregon are focusing on restoration being climate friendly because you're reusing. And that's what we feel like that is an important thing at the caves. And then we also have a wonderful scientist that you're going to hear from soon who's doing research in the cave. So I said there's two reasons why, and here I am. You know, open your mouth and here you are. So anyway, okay. So the Oregon, this is, if you have not been there, every time I drive up that road, I think, and you appear and say, how can this be so gorgeous, way up in the mountain, and be developed like it is? On the left, it is the visitor center, and that's where you buy your ticket. And the top floors are the dormitory for the guides, and this is how you'd start the tour. You take a 90-minute guided tour underground, and it just never ceases to amaze me time and time again what I learned and how educated the guides are. We do have seasonals. Of course, we don't want to think about what just happened today where they're laying everybody off that works for the federal government, if you heard that at 4:30 this afternoon. But anyway, we'll just pretend like that isn't going to happen, okay? So, let me just say, okay. So it was declared a monument in 1909, and you think about President Taft, 1909, found this place and designated it. Now, it could have been dug up. It could have been somebody's something, but instead it was a monument. And I think that's really important to realize how important things like that are, that somebody made a decision, like you're all making, working on all the things we're currently working on. Somebody then made a decision that's still important so many years later. In 2014, the Congress, it was only 480 acres. This is kind of, and Congress made it 4,000 acres, which again said it was important. It's important to the region, it's important to the economy, and we need to keep it healthy. And then the other thing that Senator Wyden just loves is underneath the caves, the Cave Creek flows through down under the monument, and it is the only national wild and scenic river that's underground. And if you see Senator Wyden, he is so proud. He doesn't want ever there to be another one because he got it designated, and so it's pretty exciting. I'm going to go to the picture of the cave. So this is just a beautiful example of what you see when you do take the tour, and they are, of course, referred to as the Marble Halls of Oregon. Recently, we just received the designation of a dark sky park. And that means, like, I was born in Lakeview. We just used to lay on the road and look at the sky. I mean, we didn't know that it was something special, that you could have a dark sky designation. But we are now a dark sky park, and the community of Illinois Valley wants to be a dark sky community. And we have to kind of say it because we can. We beat Crater Lake. You have to say that to everybody, but we kind of are happy about that. Now, we are also the home of the cavemen. And sometimes we're kind of embarrassed about it, and sometimes we think, well, you know, there's a statue at the freeway, and now if you go down to Tap Rock, there's a second caveman, because about 7 or 8 years ago, they found another one in New York. They brought it all the way to Grants Pass, and they painted it and put it up. And for a while, Grants Pass thought, we don't really want to have that be our moniker, but it is. And we at the Oregon Caves are very happy about that. Now, the new guy has bangs, and he's got a better hairdo than the first one. But so, we are the cavemen. It is what it is. And the one thing that's kind of fun is that the Oregon cavemen drove the dignitaries over the Golden Gate Bridge when it opened. And they were, because one of the Oregon cavemen was a Greyhound bus driver. So they contacted him, and then they said, well, should we wear our caveman outfits? Well, of course we could. And so the superintendent of the Golden Gate, we're going to find the picture. She thinks there is a picture of the Oregon cavemen driving the dignitaries over the Golden Gate Bridge. So, you know, they were pretty important, even though they were kind of, and that's Deb's Potts, if you guys are from the area. He was the mayor of Grants Pass, and he also was a caveman. And the people around him, they had a cave queen every year, they had cave princesses. It was quite the thing to do. And they were very thoughtful. To a point, they had a little rickety cart that they took to all kinds of parades. And I'm, again, from Lakeview. My grandfather was a friend of Deb's, and they'd grab you by your ponytail and put you in this little rickety cart and go away with you. And my grandfather was laughing because he knew it was Deb's, but Deb's had this awful outfit on, and they had these bad teeth, and they couldn't tell who they were, and I was scared to death. Okay, so in the beginning, when they very first started, they used to come by horseback over the road from Williams. 20,000 people came every year just to take a cave tour when they first started. And they, you can see the women, the women wore dresses, if you can believe it, riding those horses, and they rented coveralls for them to take a cave tour, and they made more money on the coveralls than they did on the cost of the cave tour. But that's dedication to ride a horse that far. Then I found this is 1919, and it said how you could visit the Oregon caves. And you had to come by train so far, and then you could go the last 6 miles. You had to pay $3.50 a night to stay at somebody's ranch, and then it's 50 cents for a meal, and on it went. And people still did, and they went. And then finally, in 1922, we got the road, and it's still the same road. It never changed as far as being curvy. It still is curvy. It is paved, and it's the only dead-end state highway in the state of Oregon. So in the beginning, we had the chalet. It was just one story, and I guess I've got a little pointer here, but I can just point at it. This hole right here is where the chateau then was built. So if you look at it there, the area is so small, they could have put the chateau up where you can see the cabins, but the cabins were sliding down the hill, and they knew they weren't going to last, so they knew that going up on the hill wasn't the right way to go. But so if you look there, then to the right, that hole is where then the chateau was built, and you can still see the building in the back. And it's 6 stories deep. It goes down the canyon, 6 stories, and you come in on the 3rd floor. This is the day it opened. What I love is how well dressed everybody is that's coming to the Oregon Caves up in the middle of nowhere, and their cars. And this is 1934, the day that the lodge opened. This is what it looks like today. The outside will still be the Port Orford cedar, and the design of it is what they call parkitecture, which means it looks like it just grew up right out of the ground. And it's very specifically one of the leading lodges in the Park Service, continues to be that. It has a very interesting roof line. You can see it's amazing how it was designed. It was designed by a local builder. Let's see. In the head of U.S. Bank, Sam Baker, the head of the Chamber of Commerce, and a group of Grants Pass business people decided they want to make a resort at the Oregon Caves. The person who built and the people that were involved were the Voorhees family from the Grants Pass Courier, the Golden Rule, the Harriman family from Rocky Point and Klamath Falls, and the person who actually built it was his brother-in-law, Gus Liam. And he was a builder from Grants Pass, and he's actually the designer, and they call him the architect. This is the interior, again, the day it opened. And this is the interior in 1950. Very little change, really, then. And I think this is the interior now. That's what it looks like as we speak. But you can see, and again, back to the reuse and recycle, look at the beautiful wood. Things just aren't built like that now, and we know that, and that's why we're doing restoration, not tearing it down and starting again. Some people have suggested, why don't you just tear it down? Our partners include Restore Oregon. If any of you know anything about Restore Oregon, you should, because they are wonderful partners, and they are looking at helping all across the state people that need resources to restore a building. and they believe that, that they're positioned to help reduce carbon emissions and mitigate climate change by advocating for building conservation, adaptive use, and retrofitting. The same is for the National Trust for Historic Preservation. They feel that bringing old buildings into the future through reuse and retrofitting can prevent and reduce harmful carbon emissions. So we feel like we're doing a little tiny part by restoring the lodge and not starting over. So in 2018, let's see what I've got my next slide. Okay, so these are just more of the interior shots so you can see what it looks like now, right now. If you stayed there, that's what the rooms, that's upstairs. I know, I want to do the same thing. In 2017, we were fully funded by the Park Service to do life safety and accessibility. That meant we were going to put handicap rooms, an elevator. We were going to do wiring, plumbing, everything that was going to bring it back, and we were ready to go. And then we took it down to the studs, and they decided that the foundation needed some stabilization, and we needed to do some seismic work. So we were on a pause. The Park Service was going to put out a press release and say, well, I guess we're over. This project is done. And I have to say, rarely do we just say, we stuck it out. I said to the Park Service, I don't think we need to put out a press release. How about we just wait a little while and think this over? Is there another way we can do this? And they were ready to put that press release out and be done. And I talked to him. We went about a week, and then finally we said, did any of the Blue Ribbon Committee? Did any of you remember Bob Repine when he was in the legislature down here? Great guy. David Gremmels from the Travel Oregon. We've got staff from Merkley and Wyden's office. We have Restore Oregon. We put together a group of people that said, what can we do? And they said, we're going to do what we can to get the rest of that money to get that lodge put back together. So that means that we have to find about $60 million. I know, and the longer we wait, the more it's going to cost. So we are going to the Oregon legislature for some support. We are going to do a capital campaign, and we will go to back to the Park Service, the Great American Outdoors Act, do the best we can. Park Service said it's got to be done, but it's going to take us 10 to 15 years. And we said, I'm not going to wait that long. So the kinds of things that we're doing, you can see here the balconies were taken off in 1950. Those will come back. That's one thing that the Oregon legislature and the Friends did, where we got the funding. They were not going to put those back, but that means you can sit out and have a meal out on the that would be the lobby level that you can see right there in the picture. Let's see. So our job of the Friends initially was just to bring back the historic character. That meant we were going to do the lighting, the furniture, just not trying to raise $60 million. We were just going to do everything else so that it would remain its designation of a National Historic Landmark Lodge. So we've done things like we hired, can't think of his name, Ben the Builder, I'll think of his name, and we are doing things like restoring the doors. Otherwise, Park Service would just probably go to Home Depot or someplace and buy some new doors. So we thought, okay, what can we do? They say these doors now are nicer than they probably were in the beginning. So we did that, and then the state of Oregon is funding the restoration of all the rest of the doors. We do have to make them be fire safe, which is a whole nother project that we're working on, but they will be, and we'll make sure that when the lodge opens, what our goal is, everything that can be done outside ahead of time, we're going to have it done before it would open. So that's the team there working on the doors. George Kramer is one, and then Jay over here is the guy who knows everything. Oh, I'm going the wrong way, aren't I? There we go. Okay. So you saw the earlier picture. This is what we're using now for our case statement to say what it will look like when it opens back up. We do have 400 pieces of Monterey furniture. It was purchased at Meyer & Frank in Portland, and we did that. We know that many movie stars had it in their home. We're very sad to know that Will Rogers, who had a full collection of Monterey furniture, we lost all of that in the recent California fires, which is very heartbreaking. We will have the largest collection of Monterey furniture anywhere, and the Smithsonian is working with us on that because we're going to probably put a book out eventually. But this is my office here on the bottom. We have 240 original pieces of Monterey furniture that came out of the lodge, and then we have 150 more pieces that have been donated. And we are working with Ramon Ramirez, who does the restoration of Diane Keaton's furniture, to help us put it back. We'll be the only lodge, like I said, in the Park Service as well, that has its furniture, the original furniture in the rooms, which is just another piece of the beauty of the lodge. I mean, why did they choose that furniture in 1933? We don't know, but it's fabulous and it's wonderful, and it is, again, it's made of Oregon alder and it's highly decorative, and we're going to bring it all back. So let's see, what else have I forgotten? So back to kind of what's happening at the right now. The cave tours are still running. We've recovered from the pandemic. We had a great season last year. So the tours start on the weekends in March, and they start for spring vacation. You can go up then. And then you go to recreation.gov. But if you go to recreation.gov and it says all the tours are sold out, that isn't necessarily the case. You can go to the visitor center in Cave Junction or go on up to the monument. You can probably still get a ticket. I think they need to work on that and give you a phone number. And so we're doing a new brochure, and I said, give them a phone number, even if it's a recording that says something. Don't just, because somebody tonight said, I think it was Kathy, you know, you don't know what it's like to get up there, and it's an all-day adventure. You need to drive to Cave Junction, and then drive up that little curvy road, and then, you know, and all the way down, and you don't want to get all the way up there and not have a tour, not have a ticket. So the tours are up and running. We're very excited about that. And the other piece that we're doing tonight that we want to talk about is, and I will introduce her, and I think is she coming? Is she available? Okay. The other really interesting thing is the cave is underground. I mean, you're under the ground, and so we're doing some research now. Katie Wendt is an assistant professor and senior research at the College of Earth, Ocean, and Atmospheric Sciences at Oregon State University, and she has a team, and they're researching climate change in the cave, which we think is pretty exciting down there in Cave Junction. They're mostly researching the history, the climate history of the particular region. They're not making projections of what would happen, but they're doing a lot of research. And her work has brought her to caves from all over the world, from Brazil to the Alps to the, I'm not going to say this, to the Arctic. I'll just say it that way. And so Katie's going to join you now and talk about her work. And thank you.
And by right now, we of course mean when I figure out what I'm doing. So, perfect. All right, Katie, we're ready for you.
Sounds good. Okay, hi everyone. Hopefully you can hear me and see me okay. So my name is Katie Wendt. I am an assistant professor, senior research at Oregon State University, and I'd like to talk to all of you about some of the research we've been doing in Oregon caves. So as many of you probably already know, temperatures across Oregon are projected to rise over the coming century. So this figure shows rises in temperature that are predicted for Josephine County, which is where Oregon Caves is located. And these temperature projections are out until the year 2100. So each of these colors represents a different future scenario that society might take. This red line represents business as usual, where humans continue to consume fossil fuels at the same rate that we are today. And this blue line represents a scenario where humans choose to cut back or curb their consumption of fossil fuels as soon as possible. And each of these lines represents not just one climate model, but an average of several climate models made by scientists all over the world. This is part of the CMIP, or the Coupled Modeled Intercomparison Project. And this graph is made from Climate Viewer, which is made and maintained by the USGS. It's freely available. You can go to this link and look up the temperature projections from any county in the US. So coming back to this graph, generally speaking, climate models are in agreement that temperatures in Josephine County and in the Pacific Northwest as a whole will rise in the future. But when it comes to precipitation, the model consensus tends to vary a bit. So shown here are those same models, this time showing summer precipitation in the Pacific Northwest in the 2080s relative to the second half of the 20th century. Again, you can view this data. It's freely available through the Pacific Northwest Climate Projection Tool, which is maintained by the University of Washington. And I know there's a lot going on in this graph, so I'm just going to simplify things a bit and narrow our focus to this last bar here. So shown here are the changes in precip in the summer in the 2080s using this business as usual scenario, so kind of the worst case scenario. And each of these lines represents the results of individual climate models. So there's about 20 climate models total. And the point of showing this graph is to show you that climate models are mixed. They're split. So some climate models show that conditions might get wetter in the summer in the Pacific Northwest moving into the future. And some suggest that it will get drier. And it's not just a little bit wetter, a little bit drier, but some are predicting 33% wetter during summers and others predicting 52% drier. So there's this huge mix. And which model is right? You know, what will summers look like in the Pacific Northwest in the future? That's a huge question. And one of the ways to approach this question is to use paleoclimate. So to go back in time and look at time intervals in Earth's climate history where summer temperatures were warmer than today, and then study how the hydroclimate of a particular region responded to those warmer temperatures. So the last time that summer temperatures were warmer than today was the last interglacial. So inter means between, so it's in between two glacial periods. We are currently in an interglacial today. The last interglacial occurred 130,000 years ago to about 115,000 years ago. And this map shows estimated summer temperatures during the last interglacial. And if you look at the Pacific Northwest, we can see that temperatures were about 3 to 5 degrees Celsius warmer than pre-industrial conditions, which is warmer than where we are today. I can talk about why the interglacial was so warm relative to today, maybe if folks are interested in the Q&A. But the point of this slide is really to show you that even though the climate forcings were different during the last interglacial can still be used as an analog to help us understand how the hydroclimate of the Pacific Northwest might respond to warmer temperatures, particularly in the summer. So we already have a handful of proxy records or paleoclimate records in North America. So here's a map showing where they all are. Paleoclimate records can be a number of different things: terrestrial sediments, speleothems, which we'll talk about later, lake sediments, pack rat middens, tree rings, fossils, etc., etc. In the Pacific Northwest, we do have 2 paleoclimate records that span the last interglacial, and they do suggest that conditions were drier during the last interglacial, but both of these records don't have very good resolution, and so there's a lot of questions that remain. One big question was how hot was particularly the southern Pacific Northwest during the last interglacial? How did precipitation amount and different types of precipitation patterns change, both in the summer and in the winter? Can we see any signals for what atmospheric rivers were doing, for example? In our proxy record, that would be really interesting to study how atmospheric rivers might respond to warmer conditions. So there's a lot of open-ended questions, and that's what brings us to Oregon caves. So first off, why study speleothems? When we think about paleoclimate records, folks often think about ice cores or tree rings, but caves are also really great at recording climate conditions. And they do this through speleothems. So speleothems are secondary carbonate deposits. These are these wacky formations that you see in a cave, and each of these formations is made up of thousands of tiny layers of calcium carbonate, and the chemistry of those layers provide us with clues about what the climate was doing above the cave at the time that these layers were deposited. And just a fun fact, The word speleothem is used by scientists all around the world, but it's actually a word that was invented here in Oregon by an OSU geologist named George Moore. And he did this by taking two Greek words for cave and deposit and sticking them together. So, okay, how do speleothems record past climate changes? It all comes down to how they were formed. I won't go through the chemistry here because I don't want to put everyone to sleep. But the basic idea is that if you have some sort of rain droplet that hits the surface and begins to infiltrate down through the soil column, as it does, it picks up some CO2 and creates what's known as carbonic acid. So this is a slightly acidic acid, and so we have this weak acid making its way down. It hits the bedrock, which in some cases is limestone or calcium carbonate, slowly begins to dissolve this bedrock, and eventually that tiny rain droplet reemerges in the cave as a drip. And that drip is what helps form these speleothems, these secondary deposits or these formations that we see in a cave. And what's important is that these formations are made out of calcium carbonate, but that oxygen that makes up our speleothems originated from the water droplet at the surface. And the carbon that makes up that speleothem originated from the CO2 that was absorbed in the soil column as that water droplet was making its way down. And that's important because we can look at the isotopic signature of both the oxygen and the carbon, and that can tell us something about past climate and past vegetation changes. So for oxygen isotopes, that can tell us a lot about past changes in temperature and rainfall amount. Carbon isotopes can tell us about vegetation changes. Were we in a C4 versus a C3 regime? How productive was the soil column above the cave at that given time? It can tell us a little bit about groundwater recharge changes. Growth rate, so similar to the thickness of a tree ring. If you have a really thick layer of speleothem in a particular year, that can tell you something like, drip rates were much faster, and so groundwater recharge was greater during that time. Past flood layers, so if a cave floods, it sometimes deposits a layer of sediment on the speleothem, so you can reconstruct past flood events, and then in some cases you can also identify when there was some sort of paleo-fire event above the cave. And that can be done through a number of different methods. One of them is measuring the trace metal concentrations, since really high heat events tend to mobilize metals, and that can make their way down into the environment and eventually deposit onto a speleothem. This is not an exhaustive list. There's plenty of other proxies we can use to study past climate using speleothems, but these are some of the kind of highlights. Okay, so this research that we just started is at the very beginning. So last summer, we collected a lot of preliminary data that ultimately made its way into a proposal that we submitted to the National Science Foundation in September. The first order of business was to determine the age of several stalagmites in the cave, and we targeted stalagmites that were already broken because we, of course, wanted to preserve the beauty of the cave as much as possible. So we chipped off pieces of broken stalagmites, and then we dated them using a method called uranium-thorium dating in order to determine how old these stalagmites were. So we found 2 stalagmites that grew during the last interglacial, and that's going to be plenty for us to work with to reconstruct past hydroclimate changes during the last interglacial. By accident, we actually also discovered the oldest known stalagmite in Oregon caves today. That stalagmite is over 600,000 years old, so that was a really cool discovery last summer. We also had some students come into the cave with us to collect drip water. So this is a OSU undergraduate student collecting drip water using a little vial. She's just holding it still while drops collect in her small vial, and then she measured the isotopic composition of those drip waters. Again, we're trying to understand how the isotopic signals from a rain droplet make its way all the way down into a cave and get preserved as a climate record. So kind of the first step of that is understanding modern conditions and how those signals are translated to the cave. And then we also deployed an automated drip water sampler in the cave, which is there today collecting drip water. silently and not disturbing the bats, which are currently hibernating in the cave. And then we submitted this proposal. This talk is coming at a kind of interesting time because I'm sure many of you have heard about the news of federal grants being suspended, and the National Science Foundation followed suit by freezing all reviews of proposals. So that is a huge disappointment, and we're trying to stay positive that our proposal will indeed get funded so that we can kickstart all of this really neat work that we have ahead of us. So if we are funded, this will lead to many more U-series dating, so not only uranium thorium, but also we're going to uranium lead date the oldest stalagmite discovered in Oregon caves to see just how old it really is. A graduate student can be hired, and we'll do some pretty cool science in collaboration with UC Davis in particular. There's some climate modelers at UC Davis that want to do some proxy model comparisons with us. And then lastly, some interpretive outcomes. There's a lot of people that visit Oregon caves every year. And so if you go on a cave tour from now on, the cave tour guide will point out exactly where we discovered the oldest stalagmite, so where that stalagmite is hidden in the cave. And then we've also left some waterproof tags with a QR code if folks are interested in learning more about our research. And then if our proposal is funded, it also includes some funds to build a museum display at the Oregon Caves Museum. And that will highlight some of our research findings and, more importantly, just talk about how caves are really important to protect and preserve because they record past climate, so they're excellent climate archives. And so that's all I have for you guys today. I'm happy to answer questions. I know I sort of breezed through a lot of information quickly, but thanks for listening.
Alrighty, it's dawning on me, the one thing we didn't test was how we were going to do the Q&A. So,
I thought you were just about to say that you couldn't hear me that whole time.
oh, no. Luckily we got through that and now we're at the next complicated part.
Okay.
I guess we'll hand around the mic and then we'll give it a go that way. And
Sure.
if that doesn't work, then I will think of plan B in the meantime.
Daniel, I can hand it around.
Can you ask her to maximize? Okay.
Katie,
Oh.
Katie, you said if we asked you during the Q&A to explain why the temperatures were warmer during the last interglacial, you would. So here's the question.
Yes. Okay, great. So it all comes down to the configuration of Earth as it orbits around the sun. So every 10,000 to 100,000 years or so, Earth's orbit is its configuration is slowly changing. Earth is just kind of like a spinning top, spinning in space, and those changes happen very slowly. So during the last interglacial, Earth's configuration was such that during our northern hemisphere summers, Earth was at its closest point to the sun in its orbit. That's called the perihelion. And so there was more solar radiation reaching the northern hemisphere during its summers. And so summer temperatures, particularly in the northern hemisphere, were much warmer. Now, the opposite effect of Earth during the winter, during the northern hemisphere winters, it was furthest away from the sun. So the winters were actually much cooler during the last interglacial. So we had something what's called very high seasonality during the last interglacial, which makes it an interesting time period to study. But again, so even though the last interglacial and today have different what we call climate forcings, last interglacial were changes in the amount of solar radiation reaching Earth. Today, the dominant climate forcing driving climate change is greenhouse gases. Even though there are different forcings, the outcome is warmer temperatures, so we can kind of study both time periods and study how the hydroclimate was behaving during the last interglacial and infer whether or not that can tell us about how future hydroclimate changes will take place.
Perfect, thank you.
Hi, Katie. I have a question for you that you may or may not know the answer to. It has to do with the models you showed us at the beginning and the changes in summer precipitation. And I was just curious why summer precipitation was being looked at when we hardly get any.
Right, I guess I was focusing on summer just because we're talking about the last interglacial, which has warmer summer temperatures relative to today. And so, so I was just comparing summer precip to summer precip. But you could look at winter precipitation, for example, and you'll see a pretty similar spread. There's a little bit more consensus amongst the models that winters will get wetter. But yeah, there's still some disagreement amongst the models in both seasons. You can also, using that climate viewer, look at annual precip as well.
Can you stop screen sharing so we can see you better?
That's a good idea.
There's been a request to
Can
stop
you
screen
stop
sharing.
screen sharing so we can
Oh
see you
goodness!
better?
Oh goodness! Oh yeah, and then you're like looking at my notes the whole time.
Thank you.
Hi, Katie. My question is in
There we
regards to your the model on the best and the worst case scenario for the next 100 years. What exactly are the pre-factors for the best case scenario on the blue? Like what percentage of Oregon or what percentage of the US or the globe would have to meet the best case scenario?
Yeah, that is a really good question. I used to know the answer to that. This is the problem with being a paleoclimatologist, is I spend all my time looking at the past. And so it would be a dramatic reduction. And the best case scenario would be a curbing of emissions such that Earth will not rise more than 1.5 degrees C. So we haven't yet met that, but we are very fast approaching 1.5. I think we're currently at 1.2. And so best case scenario, we would do a real fast and very dramatic curbing of our emissions today.
Considering our U.S. situation right now, are there any cooperative similar ventures going on in other countries that you cooperate with?
Yeah, so we collaborate with other universities in other countries. We're going to do what's called a fluid inclusion analysis at a university in Austria, for example. But ultimately, our funding source comes from the National Science Foundation, and so that's really the biggest concern right now. And so it's possible, I guess, to send a lot of our samples over to those colleagues and those collaborators whose governments are continuing to fund climate research in order to get our questions answered, but we're hoping to do it ourselves.
So what is the procedure with the stalagmites? Is it like ice cores and mud cores where you cut them in half and look at them through high-powered microscopes, or what are you actually doing to the stalagmites, or to,
yeah,
what's the process?
It was a little hard to hear that question, but just exactly kind of like what types of things do we do to the stalagmite?
Yeah.
Actually, I have one here. So it's mounted on this stage, but this is what a stalagmite, this stalagmite came from Oregon caves. This is what it looks like. So this was a stalagmite growing up from the ground, and if you slice it open, you might even be able to see on zoom all of the individual growth layers. So it's very much like a tree ring, where each of these layers represents an individual year history of each of these layers. Now, when it comes to dating a stalagmite, stalagmites are really special because we can use a radiometric technique called uranium thorium dating. So that allows us to determine, okay, how old is the bottom of this stalagmite, this bottom layer, how old is this top layer, okay, so what's the growth rate, and then we can assign when in time each of these layers was deposited. Any other questions? Okay. I should just mention mention that OSU has one of the world's greatest ice core labs. If you ever get a chance to get a tour of the ice core lab, they do tours all the time. It's a fantastic place to go and see. Often guests get to hold some ice from Antarctica. But here at OSU, they specialize in the measurement of greenhouse gases that are trapped in ice cores. And so you can see, what a lab that specializes in that very specific technique looks like. It's really cool.
Did you say how old that piece is that you held up?
Yeah, so this piece, I wrote it down on a sticky note because I get asked a lot by students. So this piece grew during what's called the Holocene, so that is our current interglacial period. The top of this stopped growing 460 years ago, and then the bottom here is about 10,000 years old. So really slow growth rate through this stalagmite. I have another stalagmite sitting here, which is actually in pieces because we've been analyzing it. That actually did grow during the last interglacial. So, yeah.
Any other questions?
Perfect. Well, Katie, thank you so much for joining us today. We really appreciate you.
Yeah, thank you.